Hi, I'm Adrienne Davis, Customer Success Manager on the CSO side of the house at Mirantis. With me today is Artem Andreev, Product Manager and expert who's going to enlighten us today.
Hello, everyone. It's great to hear all of you here listening to our discussion today. So my name is Artem Andreev. I'm a product manager for Mirantis OpenStack line of products that includes the current product line that we have and the next generation product line that we're about to launch quite soon. And actually, this is going to be the topic of our presentation today. So the new product that we are very excited about and that is going to be launched in a matter of several weeks is called Mirantis OpenStack on Kubernetes. For those of you who have been with Mirantis quite a while already, Mirantis OpenStack on Kubernetes is essentially a reincarnation of our Mirantis Cloud Platform version 1, as we call it these days. So, and the thing has reincarnated into something more advanced, more robust, and altogether modern, that provides the same, if not more, value to our customers, but packaged in a different shape. And well, we are very excited about this new launch, and we would like to share this excitement with you, of course. As you might know, recently, a few months ago, Mirantis acquired Docker Enterprise together with the advanced Kubernetes technology that Docker Enterprise provides. And we made this technology the piece and parcel of our product suite. And this naturally includes Mirantis OpenStack on Kubernetes as well, since this is a part of our product suite. And well, the Kubernetes technology in question we call Docker Enterprise Container Cloud these days. I'm going to refer to this name a lot over the course of the presentation. So I would like to split today's discussion into several major parts. So for those of you who do not know what OpenStack is in general, a quick recap might be helpful to understand the value that it provides. I will discuss why someone still needs OpenStack in 2020. We will talk about what a modern OpenStack distribution is supposed to be, the expectation that is there. And of course, we will go into a bit of details about how exactly Mirantis OpenStack on Kubernetes works, how it helps to deploy and manage OpenStack clouds.
So set the stage for me here. What's the base environment we're trying to get to?
So what is OpenStack? One can think of OpenStack as a free and open source alternative to VMware, and it's a fair comparison. So OpenStack, just as VMware, operates primarily on virtual machines. So it gives you as a user a clean and crispy interface to launch your VM, to configure the virtual networking to plug this VM into, to configure and provision virtual storage to attach to your VM, and do a lot of other things that actually a modern application requires to run. So the idea behind OpenStack is that you have a clean and crispy API exposed to you as a user, and all these little details and nuances of the physical infrastructure configuration and provision that need to happen just for the virtual application to work are hidden and spread across multiple components that comprise OpenStack per se. So as compared, again, to VMware, the functionality is pretty much similar, but actually OpenStack can do much more than just VMs, and it does that, at frankly speaking, at a much less price, if we do the comparison. So what OpenStack has to offer? Naturally, the virtualization, networking, storage systems are there. It's just the basic entry-level functionality. But of course, what comes with it is the identity and access management features, graphical user interface together with the CLI command line tools to manage the cloud, orchestration functionality to deploy your application in the form of templates, ability to manage bare metal machines, and of course some nice and fancy extras like DNS as a service, metering, secret management, and load balancing. And frankly speaking, OpenStack can actually do even more. depending on the needs that you have.
We hear so much about containers today. Do applications even need VMs anymore? Can't Kubernetes provide all of these services? And even if IaaS is still needed, why would one bother with building their own private platform if there's a wide choice of public solutions for virtualization, like Amazon Web Services, Microsoft Azure, and Google Cloud Platform?
Well, that's a very fair question, and you're absolutely correct. So the whole trend is containers these days. Everybody's talking about containers, everybody's doing containers, but to be realistic, yes, the market still needs VMs. There are certain use cases in the modern world, and actually these use cases are quite new, like 5G, where you require high performance in the networking, for example. And you might need high performance computing and as well. So, and this takes quite a special hardware and configuration to be provided within your infrastructure that is much more easily solved with the VMs and not containers. Of course, not to mention that, well, there are still legacy applications that you need to deal with, and that, well, they have just switched from the server-based provisioning to VM-based provision, and they need to run somewhere. So they're not ready for containers. And well, if we think about, okay, VMs are still needed, but why don't I just go to a public infrastructure as a service provider and run my workloads there? Yes, you can do that, but well, you have to be prepared to pay a lot of money once you start running your workloads at scale. So public IaaSs, they actually tend to hit your pocket heavily. And of course, if you work in a highly regulated area, like enterprises, government, etc., so you have to comply with a lot of security regulations and data placement regulations. And while public IaaSs, let's be frank, they're not good at providing you with this transparency. So you need to have full control over your whole stack, starting from the hardware to the very, very top. And this is why private infrastructure as a service is still a thing in these days. And I believe that it's going to be a thing for at least 5 years more, if not more.
So if private IaaS are useful and demanded, why doesn't Mirantis just stick to the OpenStack that we already have? Why did we decide to build a new product rather than keep selling the current one?
Well, to answer this question, first we need to see what actually our customers believe a modern infrastructure as a service platform should be able to provide. And we've compiled this list into like 5 criteria. Naturally, private IaaS needs to be reliable and robust, meaning that whatever happens underneath the API, that should not be impacting the business-generated workloads. This is a must, or impacting them as little as possible. The platform needs to be secure and transparent, going back to the idea of working in the highly regulated areas. And this is, again, a table stake to enter the enterprise market. The platform needs to be simple to deploy and operate, because, well, you as an operator, you should not be thinking about the internals, but rather focusing on enabling your users with the best possible experience. Updates are very important. So the platform needs to keep up with the latest software patches, bug fixes, and of course features. And upgrading to a new version must not take weeks or months, and has as little impact on the running workloads as possible. And of course, to be able to run modern application, the platform needs to provide the comparable set of services as just as a public cloud, so that you can move your application across your tenants in a private or public cloud without having to change it severely. So so-called the feature parity needs to be there. And if we look at the architecture of OpenStack, and we know OpenStack is powerful, it can do a lot. We've just discussed that, right? But the architecture of OpenStack is known to be complex. And well, tell me, how would you enable the robustness and reliability in this complex system? It's not easy, right? So, and actually this diagram shows just like probably a third part of the modern OpenStack cloud. So it's just a little illustration. It's not the whole picture. So imagine how hard it is to make a very solid platform out of this architecture. And well, naturally, this also imposes certain challenges to provide the transparency and security, because well, the more complex the system is, the harder it is to manage, and well, harder it is to see what's on the inside. And well, upgrades. Yeah, one of the biggest challenges that we learned from our previous history, well, that many of our customers preferred to stay on the older version of OpenStack just because, well, they were afraid of upgrading, because they saw upgrades as time-consuming and risky endeavors. And well, instead of just switching to the latest and greatest software, they preferred reliability by sticking to the old stuff. Well, why? Well, because potentially that meant implied certain impact on their workloads, and well, that the an upgrade required thorough and planning and execution, just to be as riskless as possible. And we are solving all of these challenges of managing a complex a system as complex as OpenStack is with Kubernetes.
So how does Kubernetes solve these problems?
Well, we look at OpenStack as a typical microservice architecture application that is organized into multiple little moving parts, daemons that are connected to each other and that talk to each other through the standard API. And altogether, that feels a very good fit to be run on top of a Kubernetes cluster, because many of the modern applications, they follow exactly the same pattern.
How exactly did you put OpenStack on Kubernetes?
Well, that's not easy. I'm going to be frank with you. And if you look at the architectural diagram, so this is the stack of Mirantis products represented with a focus, of course, on the Mirantis OpenStack as a central part. So what you see in the middle, shown in pink, is Mirantis OpenStack on Kubernetes itself. And of course, around that are supporting components that are needed to be there to run OpenStack on Kubernetes successfully. So on the very bottom, there is hardware, networking, storage, computing hardware that somebody needs to configure, provision, and manage to be able to deploy the operating system on top of it. And this is just another layer of complexity that abstracts the Mirantis OpenStack on Kubernetes from the underlay. So once we have operating system there needs to be a Kubernetes cluster deployed and managed. And as I mentioned previously, we are using the capabilities that this Kubernetes cluster provides to run OpenStack itself, the control plane of it, because everything in Mirantis OpenStack on Kubernetes is a container, or whatever you can think of. So, and well, of course, naturally, it doesn't sound like an easy task to manage this multi-layered pie. And this is where Docker Enterprise Container Cloud comes into play, because this is our single pane of glass into day 1 and day 2 operations for the hardware itself, for the operating system, and for Docker Enterprise Kubernetes. So it solves the need to have this underlay ready and prepared. And once the underlay is there, you go ahead and deploy Mirantis OpenStack on Kubernetes just as another Kubernetes application following the same practices and tools as you use with any other application. So naturally, of course, once you have OpenStack up and running, you can use it to create your own, to give your users ability to create their own private little Kubernetes clusters inside OpenStack projects, and this is one of the major use cases for OpenStack these days, again, being an underlay for containers. So if you look at the operator experience, how does it look like for a human operator who is responsible for deployment and management of the cloud to deal with Mirantis OpenStack and Kubernetes? First, you deploy Docker Enterprise Container Cloud, and you use the built-in capabilities that it provides to provision your physical infrastructure. You discover the hardware nodes, you deploy operating system there, you do configuration of the network interfaces and storage devices there, and then you deploy a Kubernetes cluster on top of that. This Kubernetes cluster is going to be dedicated to Mirantis OpenStack on Kubernetes itself. So it's a special utility, not general purpose thing that, well, is dedicated to OpenStack. That means that inside of this cluster, there are a bunch of lifecycle management modules running as Kubernetes operators. So OpenStack itself has its own LCM module or operator. There is a dedicated operator for Ceph, because Ceph is our major storage solution these days that we integrate with. Naturally, there is a dedicated lifecycle management module for Stacklite. Stacklite is our operator login monitoring alerting solution for OpenStack and Kubernetes that we bundle together with the whole product suite. So Kubernetes operators directly through kubectl command or through the graphical wrappers that are provided by Docker Enterprise Container Cloud as a part of it, to deploy the OpenStack, Ceph, and Stacklite clusters one by one and connect them together. So instead of dealing with hundreds of YAML files, well, it's 5 definitions, 5 specifications that you're supposed to provide these days, and that's it. And all the day 2 management is performed through these APIs just as the deployment, as easily.
All of this assumes that OpenStack is containerized. Now, Mirantis was containerizing OpenStack long before Kubernetes even came along. Why did we think this would be important?
That is true. Well, we've been containerizing OpenStack for quite a while already. It's not a new thing at all. However, it's the way that we deploy OpenStack as a Kubernetes application that matters, because Kubernetes solves a whole bunch of challenges that we had used to deal with MCP1 when deploying on top of the bare operating, when deploying OpenStack on top of bare operating systems as packages. So naturally, Kubernetes provides us with allows us to achieve reliability through the self-healing and auto-scaling mechanisms. So you define a bunch of policies that describe the behavior of OpenStack control plane, and Kubernetes follows these policies when things happen, and without actually any need for human interaction. So isolation of the dependencies for OpenStack services within Docker images is a good thing, because previously we had to deal with packages and conflicts in between the versions of different libraries. So now we just ship everything together as a Docker image and are happy with that. Rolling updates is an advanced feature that Kubernetes provides natively. So updating OpenStack has never been as easy as with Kubernetes. Kubernetes also provides some fancy building blocks for networking, like load balancing and, of course, Calico tunnels and service meshes. They're also quite helpful when dealing with such a complex application like OpenStack, when things need to talk to each other and without any problem in the configuration. So Helm reconciling plays also a great deal of overall. So it actually is our solve for Kubernetes. We are using Helm bundles, which are provided for OpenStack in the upstream as our low-level layer of logic to deploy OpenStack app services and connect them to each other. And well, naturally, automatic scale up of control plane. So adding a new node is easy. You just add a new Kubernetes worker, put a bunch of labels there, and well, it handles the distribution of the necessary service automatically. Naturally, there are certain drawbacks. So these fancy features come at a cost. Human operators, they need to understand Kubernetes and how it works. So, but this is also a good thing because everything is moving towards Kubernetes these days. So you would have to learn at some point anyway. So you can use this as a chance to bring yourself to the next level of knowledge. There is, well, OpenStack is not a 100% cloud native application by itself. Unfortunately, there are certain components that are stateful, like databases or Nova compute services or OpenSwitch daemons, and that have to be dealt with very carefully when doing upgrades, updates, and well, the whole deployment. So there's extra lifecycle management logic built in that handles these components carefully for you. So a bit of a complexity we had to add. And naturally, Kubernetes requires resources, computing resources itself to run. So you need to have these resources available and dedicated to Kubernetes control plane to be able to control your application that is OpenStack itself. So a bit of an investment is required.
Can anybody just containerize OpenStack services and get these benefits?
Well, yes, the idea is not new. There's a bunch of upstream community projects doing pretty much the same thing. So we're not inventing a rocket here. Let's be fair. However, it's only the way that Mirantis cooks OpenStack gives you the robustness and reliability that enterprise and like big customers actually need. And we're doing a great deal of a job automating all the possible day two workflows and all these caveat complexities of the OpenStack management inside our products. Okay, at this point, I believe we shall wrap this discussion a bit up. So let me conclude for you. So OpenStack is an open source infrastructure as a service platform that still has its niche in 2020, and it's going to have its niche for at least 5 years. OpenStack is a powerful but very complex tool, and the complexities of OpenStack and of OpenStack lifecycle management are successfully solved by Mirantis through the capabilities of Kubernetes distribution that provides us with all the necessary primitives to run OpenStack just as another containerized application these days.